a gamma model, this Heisenberg-Kadev gamma model, where we have the Heisenberg coupling and the Kadev coupling we saw before, but we also have this symmetric off-diagonal exchange. So the structure of this, so the Kadev bonds, for example here, the Z components of the spins are coupled, and then for this gamma term, it's the X and the Y that are coupled on this bond, and you cyclically permute it. So within the super exchange calculation, once you include DD hopping, as well as the oxygen-mediated hopping, you generate this immediately. Essentially, you go through the oxygen one way and then back to the d orbital. So it's a cross term between this direct DD hopping and this oxygen-mediated hopping. So I just want to emphasize that even without the distortions, this is not Heisenberg-Kadev. Okay, so what does this do? So I've sort of organized this into a similar phase diagram as you saw in the last talk, where what I've put is the Heisenberg-Kadev model on the outside of this ring. And then as you move in, you're turning on this gamma term. Okay, so in addition to all the phases we saw in the Heisenberg-Kadev limit, there's actually two new sets of phases. So there's this 120-degree order, which is sort of reminiscent of something you might see on the triangular lattice, except it's sort of on both of the sublattices of the honeycomb. There's a new zigzag region here that comes in for large gamma, and there are incommensurate spiral orders that appear near the ferromagnetic limit, ferromagnetic Kadev limit. So this is all classical. So what are these incommensurate phases? I've sort of labeled them kind of roughly here. This one region just means that the dominant wave vector of the state is in the first Brane zone. 2 means it's in the extended Brane zone. So this dominant wave vector changes as you move through the phases somewhat smoothly. They're not single Q states, so I'm not sure if I want to call them multi-Q, but they're definitely not single Q spiral states. And this phase 1 is actually quite energetically close to the zigzag phase. Okay, so again, these are highly quantum mechanical systems. Does any of this hold up? To try to look whether quantum effects could be important here, we did a sort of a small-scale exact diagonalization study, 24 sites. So you can capture essentially everything except the spiral order in a cluster of that size. The 120 fits, the zigzag fits, the stripy fits. And so you can see those clearly here, where I've colored this phase diagram based essentially on the dominant part of the static structure factor. And so here you can see this sort of tiny Kadev phase here where the liquid is a little bit stable to the addition of J and gamma. It's a little bit wider here, but it's unclear whether it survives too much with finite gamma. Where in the middle here, it's unclear what all of the phase is. So classically, this is the region where there's an incommensurate spiral. So if we're talking about a 24-site cluster, it's unclear whether we could really capture that properly anyway. Okay, so in principle, I've sort of failed here, right? I told you I want to find a zigzag phase near the ferromagnetic Kadev limit by looking at the simplest consistent model, and all I found were incommensurate spirals. So let's go to the next simplest model. So one could in principle add monoclinic distortion, trigonal distortion, further neighbor couplings on that trigonal distortion. So in the crystal structure, the sodium has a trigonal compression out of the plane. If you sort of go through this, you can find that it introduces a single nearest neighbor coupling in addition to the 3 you already had. So it's sort of a cousin of this symmetric off-diagonal exchange. Instead of for example, on the Z bond, instead of X and Y coupling, you have X and Z coupling and Y and Z coupling. And if you do sort of a rough microscopic calculation of this, for trigonal compression, you might expect it to come out negative. But we're going to focus on adding a negative gamma prime when thinking about this sodium iridate. Yes. One spiral phase runs to quite close together. And remember that is negative gamma prime actually flips the balance among the 2 places. So this one phase,
は土石流や氾濫で家ごと流される恐れがあります。自宅にどんな危険があるのかを知った上でどう行動すべきなのかをよく考えておく必要があります。早めの避難が最も重要です。真夜中の今、鬼怒川の氾濫などで孤立している人は無理に外に出ないで救助を待つ方が安全でしょう。ただ今後の雨次第では水かさが増す恐れもあるので、ラジオなどで最新の情報を入手するとともに非常用の持ち出し袋を準備しておくなど、すぐにでも避難できるようにしておいてください。その他、これから強い雨雲がかかる恐れがある東北の地域の人などは避難所や避難経路を確認しておいてください。参考になるのが洪水や土砂災害などの危険な地域を示したハザードマップです。こちらは国土交通省のハザードマップのポータルサイトです。全国の市区町村が公表している洪水や土砂災害などのハザードマップを探すことができます。市区町村によっては各家庭に配っているところもありますが、大抵はそれぞれのホームページでも見られます。こちらは昨日鬼怒川が氾濫した茨城県常総市の洪水ハザードマップです。今回の浸水範囲が想定通りだったかはまだ分かりませんが、予想される浸水の深さのほか避難所の場所などが載っています。他の地域でもハザードマップをもとに自宅や今自分がいる場所にどんな危険があるのか、避難所はどこなのか、その避難経路に危険はないかなどを確認しておくことが大切です。関東や東北にはまだ湿った空気が流れ込み、理解が必要です。記録的な雨が降った地域では雨が弱まっても洪水や土砂災害の危険性が高い状態が続いています。最新の気象情報や自治体からの避難の情報に注意し、状況によっては十分に注意しながら早めに避難してください。